plants live the ultimate sedentary lifestyle. Most of us usually think of plants more as objects than as organisms, but because plants can't move, they've had to evolve a whole other way to escape threats to their well-being. Plants can sense and respond dynamically to all sorts of stimuli: chemical concentrations in the air, soil, and water, touch, motion, vibration, pathogens, predators, and of course light. And how do they respond? They respond biochemically. They manufacture from scratch a dizzying array of compounds to deal with specific threats. If we get too hot, we can move into the shade, but if plants get too hot, they're stuck. They are the shade. As a result, the complexity of the plant stress response humbles that of animals. Plants and their stress response have been evolving for almost 1 billion years, and in that time they've created a whole chemistry lab of protective substances, some of which can induce similarly protective responses in those that eat them. Why is it that the best grapes in terms of health benefit often result from relatively dry, sun-exposed, infertile soil? Similarly, drought-stressed strawberries have more antioxidants and phytonutrients. Indeed, commonly consumed foods like lettuce and fruits can be nutritionally enhanced by cold stress, light stress, water deficit, or nutrient deficit stress. Why is it that stressed plants are often the healthiest? We used to think it was just a matter of using the same tools to deal with the same problems. Studies suggest that plants and animals largely share the molecular pathways in order to respond to stress, so it's conceivable that a molecule produced in plants might also be effective in people. Plants have DNA. Humans have DNA. The UV rays in sunlight can damage the DNA in plants in the same way it can damage our DNA by creating free radicals. Plants figured out how to cook up all these complex antioxidants, and instead of just reinventing the wheel, animals can just expropriate those antioxidants from plants and commandeer them for the same purpose. We get attacked by bacteria, plants get attacked by bacteria. So, for example, when this fungus doesn't like getting muscled in on by bacteria, it creates a molecule called penicillin, provided free to us. What a nice guy, what a fungi. When plants get infected, they produce aspirin, which can come in handy when we get infected. Plants heal wounds. We heal wounds, actually using similar fatty acid signaling systems. It is increasingly evident that plants and animals differ less than we thought in terms of how we all respond, sharing elements of fatty acid, protein, steroidal, neurotransmitter, free radical, nitric oxide, and even plant growth hormone signaling systems. So in a sense, we're just opening up nature's drugstore when we pull out the CRISPR in our fridge.